I'm Rebecca Harris. I am a textile engineer slash manufacturing manager at Allergan Textiles, and I'm going to really nerd out and talk about biomedical textiles. So I changed from English to textiles. So what are biomedical textiles? They are surgically implantable with a variety of end uses, pretty much anything you can think of. There's cardiovascular, orthopedic, tissue engineering, soft tissue repair, that's just the beginning. So cardiovascular, this is a vascular graft which is used to fix diseased blood vessels. These usually retail for thousands of dollars, and they're generally made out of polyester and probably don't take that long to make. Orthopedic, this is an ACL scaffold. If you happen to tear your ACL, this could be used instead of your own hamstring or a cadaver tendon. That's a very, very common surgery. This is a great use for that. Tissue engineering, this happens to be a 3D tubular knit implanted with pancreatic islands for diabetes treatment. So this would help with insulin production for somebody who can't do that quite as well. Soft tissue repair, you have probably heard of hernia mesh. This is another very common use for this, usually made out of polypropylene. There are lots of people in this market. Aside from that, there are new developments like a silk-based brain implant. This one uses thin metal electrodes with silk proteins. This can be used for helping to control seizures. They're much more pliable and take less space. These are made with all sorts of textile techniques, usually done in clean rooms. So you've got weaving, braiding, nonwovens, weft and warp knitting. They're generally standard textile machines. These are great because they're flexible, they're strong, and they're biocompatible. So wherever you can put something into the body, these will fit in there if you've got the right surgeon. So weaving is one way of doing this. In this, the yarns cross at right angles. They're not very porous, so if you want something that's not going to leak, you want something that's woven. They are very stable, but they're not stretchy. Braiding is also very similar. It's done slightly differently. It's very easy to do three-dimensional forms with braiding. The yarns cross at oblique angles. They're very flexible and porous, and they also distribute loads efficiently. Nonwovens, basically felting. They're formed from fibers or filaments. They're melted together or needle felted. These have a lot of excellent permeability, but they may have lower mechanical properties than other fabrics. Knitting, which is what I do, you have yarns that form interlocking loops. They're porous, highly conformable and elastic, and they've got high burst and tensile properties. There are two kinds of knitting. There's weft and warp knitting. Weft is more like hand knitting. It's usually made on circular or flat knitting machines where the yarn is carried across a bed of needles. These fabrics tend to be very stretchy, but they can be unstable unless they are, the pattern or the yarn is different. Warp knitting is more like weaving. They use warp beams like in weaving with one yarn end that goes per needle in general. They resist unraveling when cut, which gives them an advantage over woven fabrics. There are a variety of yarns that can be used. There are non-absorbable yarns like polypropylene, polyester, and PEEK. And then there are absorbable yarns, polyglycolides, polyactides, and silk. Other materials that can be used, a lot of different metals, nitinol, stainless steel, cobalt, chromium alloys, and titanium. It all depends on the ultimate end use for these materials. The design process in general involves a ton of people, medical device engineers, textile engineers, quality assurance and regulatory. There's lots of testing and studies done, and this is a very highly regulated industry. It often takes 4 to 10 years for approval. The manufacturing process, very quickly receive the raw materials, do some QA testing, do the textile process, it's finished, it's sterilized, packaged, more testing, and then it's shipped to distribution or the customer. Some local places that you may have heard of that make biomedical textiles: Medtronic, Boston Scientific, Biomedical Structures, Covidien, and Allergan Medical. And in summary, biomedical textiles are very versatile, diverse, made for specialized needs, and they are kind of the future of high-tech manufacturing in the United States. So,